Okay, here we're doing homework problem similar to problem number 1. This is we're going to evaluate homework problem number 2. Here in each of the problems, evaluate the limit or conclude that the function tends to infinity or negative infinity. Use the division of numerator and denominator by the highest exponent of x. And so here we have the limit of 2x squared plus 3x plus 4 over x squared minus 2x plus 3. So the first thing we're going to do is, because if we substituted infinity is not a number. If we substituted infinity, this would be 2, this would go to infinity, this would go to infinity, you'd have infinity, and here this would be infinity, it would be infinity over infinity, and you wouldn't get anything. So with infinity, you can't just substitute it in like you can if you had a specific number that x was tending towards. So one of the methods we can do is we can multiply this by 1. Well, here we can't just multiply by 1, but we can multiply it by a number over itself, because any number over itself is 1. So what we do is we look at the highest exponent for x. When here we have x squared. And we're going to multiply the reciprocal of that. So 1 over x squared over 1 over x squared is still 1, because anything over itself except for 0 over 0 is 1. And so from here, we're going to distribute that, multiply each term in the numerator, multiply each term in the denominator. Okay, and then I'll explain why we're doing that here in a moment. So here we have the limit as x tends towards infinity of 2x squared over 1 times 1 over x squared plus 3x over 1 times 1 over x squared plus 4 over 1 times 1 over x squared. And that will be over x squared over 1, that's this one here, times 1 over x squared minus 2x over 1 times 1 over x squared plus 3 over 1 times 1 over x squared. Okay, well, all this can be combined into the limit as x approaches infinity. And so you always want to write this limit for each problem until you actually substitute them in. So we're going to do that in every step. And so this will be 2x squared times 1 over 1 times x squared will be 2x squared over x squared plus 3x over x squared plus 4 over x squared over x squared over x squared minus 2x over x squared plus 3 over x squared. All right, and so from here, we're going to go ahead and apply the limit to each one of these. So this will be the limit x goes to infinity of, well, before we do that though, we have to simplify. So x squared over x squared, that goes to 1, and that's just 2. And so 3 goes into x, and we get plus 3 over x. And then plus 4 over x squared, nothing simplifies there, over. And here x squared goes over x squared, and that's just 1. Minus 2x goes in x squared, and that's 2 over x, plus 3 over x squared. Okay. So now we can go ahead and apply the limit to each one. So the limit of x tends towards infinity 2 plus the limit of x tends towards infinity of 3 over x plus limit as x tends towards infinity of 4 over x squared over. And then we can do the same thing for the denominator. The limit of x tends towards infinity for 1 minus the limit as x tends towards infinity of 2 over x plus the limit as x tends towards infinity for 3 over x squared. Well, why are we even doing this? Well, because if we have, let's look at fractions for a moment. As we have, let's look at 1/2. Now, if we look at 1 over x, for example, where x goes to infinity, well, as x gets larger, 1 over 2, 1 over 3, 1 over 4, 1 over 5, as the denominator gets larger, the fraction gets smaller, to where you get into really large numbers for the denominator, 1 over 1,000, 1 over 1,000,000, 1 over 1,000,000,000, and so you get it smaller and smaller and smaller. So as the fraction, as the denominator gets larger, the fraction, as you tend towards infinity, the fraction goes smaller and smaller and smaller until it's tending to 0. So anywhere where there's an x in the denominator, that is going to go to, that fraction is going to tend to 0. So the limit of a constant is just that constant. And so now once we apply the limit to the term, we don't need to rewrite limit of x tend towards infinity anymore. So here, this will be 3 over 100, 1,000,000, 1,000,000,000. It'll go to 0, tends to 0. So the limit over 4 over x squared, that tends to 0 over. Limit of a constant is just that constant, minus the limit of 2 over x. Again, this will go to 0, plus the limit of 3 over x squared, that'll go to 0. And so 2 plus 0 is 2. 1 minus 0 plus 0 is 1. So 2 over 1 is 2, and that is our answer. So we can check that on the calculator by graphing it. And let's see how that looks. So if we put in our function, 2x squared plus 3x plus 4 over x squared minus 2x plus 3, and we graph it, we can see, now what I did is I adjusted the window. I put Y max at 5 and X max at 100 to get a clear picture. And so here's 1, 2, and you can see that that graph is tending to 2. That limit is tending towards 2 as X gets larger and larger and larger. So it shows graphically at 2. So you have to show your work algebraically on the homework, but you can check your answer graphically on the computer. And that's our video, and I hope this helps you. Please let me know if you have any questions, and have a great day. Thank you.